Okay, so we already solved for the equation. Now we know that the volumetric flow rate is Q is equal area times velocity. Now we move on into this problem. Let's start to solve this problem. Say there is one system. There are three pipes. There are three input pipes. Input pipes just steadily deliver water to a bigger pipe. Let's say there is three input pipes and one output pipe. They have different diameters for each pipe. For the first pipe, it has 4 centimeter of diameter. The second pipe has 5 centimeter. The third pipe has 6 centimeter, and the big pipe, the output pipe, or the fourth pipe, has 9 centimeter. Now, the velocity of the second pipe is 5 meter per second, and the volumetric flow rate of the fourth pipe is 120 cubic meter per hour. Now we know that the extra information says that if it is known that increasing Q3 by 20% would increase Q4 by 10%. So determine A, the V4, or the velocity of the fourth pipe. And the second question is the velocity of the third pipe. And the last question is the velocity of the first pipe. Now let's start with the first question. We know that the A, V4, we know that the volumetric flow rate of the fourth pipe is 120 cubic meter per hour. Now before we calculate the velocity, we need to convert the units into the international system. So if we change it into international system, so we like to change the hour into seconds. So let's say 120 meter cubic per hour times 1 hour is equal to 3,600 seconds. So it will be, let me take my calculator. So it's just 120 divided by so it's actually 0.033 cubic meter per second. Now the area. Now we need to know the area of the fourth pipe. So the area of the fourth pipe is V times diameter per over 4. Now the diameter is centimeter. Now we need to change it first. We need to change the diameter. Say this is P4 is equal 9 centimeters is equal to 0.09 meter. So for the international system has, for the length units we are using meter, and for the time unit we are using seconds. So this will be P times 0, sorry, this should be square, 0.09 meter square over 4. So the area of the fourth pipe is V times sorry, this is 0.00636 square meter. Now we know that the velocity from the equation that this should be a smaller phi. The fourth pipe is equal to Q4 divided by the area of the fourth pipe. So 0.033 cubic meter per second over 0.00636 square meter is equal this is 5.24 meter per second. So this is the answer. So the answer for the fourth pipe velocity is 5.24 meter per second. Now let's solve for the second question, B. B is the velocity of the third pipe. Now, before we solve the equation, we need to know the volumetric flow rate of the third pipe. Now, from this information, that it is known that increasing flow rate by 20%, increasing the third pipe flow rate by 20%, it will increase the flow rate of fourth pipe by 10%. If you write this down as an equation, it will be, the statement as an equation, it will be the 20% of Q3, 20% of Q3 will be equal to 10% of Q4. Now, this is the statement that we need to understand to solve this problem. So if we simplify, so 0.2 Q3 is equal to 0.1 Q4. Q3 will be equal to 0.1 over 0.2 Q4, or half of Q4. So Q3 is actually 1/2 of Q4. So we already know that Q4 is 0.033 cubic meter per second. So Q3 will be equal to 1/2 times 0.033 cubic meter per second. Equal, calculator, 0.03 divided half is around 0.01665 cubic meter per second. Now we have all the information to calculate the velocity of the third pipe. So phi3 is equal to Q3 over the area of third pipe. Oh, we haven't calculated the area of the fourth pipe. So see, the area of the fourth pipe is P times 6 centimeter. 6 centimeters. 6 centimeter is equal to 0.06 meter squared over 4, equal to, say, P times 0.06 divided by 4. this is 0.00283 square meter. Now if we put it here, so it's equal to 0.01665 cubic meter per second over 0.0283 square meter. It's equal to, wait a second, 0.01665 divided by 0.00283. Yeah, so the velocity will be 5.89 meter per second. Now this is the velocity of the third pipe. So let's say the velocity of the third pipe is 5.89 meter per second. Let's solve the last question. So let's solve the last question. So the last C is what is V1? The velocity of the first pipe. Now we have no idea what is, we don't know, we have no information on the first pipe, and we also have no idea what is the volumetric flow rate of the first pipe. So we have to analyze the system first. So first we analyze the system. There are 3 input pipes equal to 1 output pipe. So if we if you write down the equation, the system, if you write down as an equation, so it will be Q1. Sorry, let's start with the beginning. So the input is equal to output, right? So this is the concept of the system. So the input is always equal to the output. So the input, we have 3 pipes for the input. So Q1 plus Q2 plus Q3 is equal to Q4. So the volumetric flow rate of all 3 pipes, of all 3 input pipes, must be equal to the output pipe, the Q4. So Q1 plus Q2 plus Q3 has to be equal to Q4, unless there is friction, of course. But this is incompressible flow, and it's a steady flow with no friction. So let's say the Q1. So we have to know the value of Q2, Q3, and Q4 before we can solve for Q1. So we already solved for Q4. Q4 is 120 cubic meter per hour, and we also have already solved for Q3. So Q3 is actually 0.01665 cubic meter per second. Now we have to solve for the volumetric flow rate for the second pipe. So we have all the information here for the second pipe. So the Q2 is equal to the area of the second pipe times the velocity of the second pipe. So it's equal to V times 0.05 meter square to the power 2 over 4 times the velocity. We already know the velocity is meter per second. Now it's just have to calculate another. So it's up 0.05 square times V over 4 times 5. It's 0. So the volumetric flow rate for the second pipe is 0.00982 cubic meter per second. Now we have all the information for the flow rate. Let's write down the equation again. So Q1 plus Q2 plus Q3 is equal to Q4. Now Q1 is equal to Q4 minus parentheses Q2 plus Q3. So for Q4, the Q4 is 0.033 cubic meter per second minus Q2 is this one. This is Q2, 0.00982 cubic meter per second plus Q3 is 0.01665 cubic meter per second. Now let's solve for this one. Say 0.0333 minus 0.00982 times 0.01665 is equal to 0.00686 cubic meter per second. Now we already know the volumetric flow rate for the first pipe, so we can calculate. So we can solve for the velocity. So velocity of the first pipe is equal to volumetric flow rate divided by the area of the first pipe. Now the volumetric flow rate of the Q1 is 0.00686 cubic meter per second divided by the area. The area is V times the diameter is 4 centimeters, so 0.04 meter squared over 4. Now let's calculate the solution. So it's actually 0.00666 divided by V times 4 square by 4. So it's the velocity is around 5.46 meter per second. This is the velocity of the first pipe. So this is 5 0.46 meter per second. Now, so that's it. We solved the problem. We solved all the basically we solved all this problem just by using one equation. Well, the thing that you need to realize that although it's a simple problem, it gets a little bit more confusing unless you can analyze the system. So you first have to analyze the system. You have to know the input, how many the input pipes and how many the output pipes, so you can make changes like the statement here, like 20% Q3 equal to 10% Q4, and this one also the amount of volumetric flow rate to get the extra information. So yeah, this is one of the easier example for the problem in fluid mechanics. So that's it.